Hello, my name is Amjad. Today I am going to present a lesson which is the slides are taken from A level computer science curriculum OCR and PG online is the website where it's located. So I just took one presentation to present it. What is the reason why I selected this topic? Is logic gates and truth tables. The topic is very interesting for the computer professionals, the students or the professional who are working on computing technology, and they are doing the programming, or they are just the analyst or data scientist, etc., etc. Plus, I will present in this lesson in such a way that any beginner can learn this topic as well. So that if we see this topic, logic gates means how the computer perform the logic through their circuits. Let me tell you a very interesting thing. Computer only understand 0 and 1 means if the circuit is 0, if circuit is off is 0, if circuit is on is 1. Imagine only taking 0 or 1, computer is doing amazing thing for you. So calculation is a bit logical. You can understand that if we type 9 and say add it into 10, it will give 19. It's not a complex thing for the computer, adding or subtraction, because already calculators are doing the work. But basically, the logic is the job which computer is doing for us through these circuits. One circuit mean either is off, either on. So it's very interesting, and if you just concentrate on the lesson, it's really very interesting. So if we start from slide 1, which is the title, objectives, we will construct truth tables for a variety of logic gates. Logic gates, I will tell you what they are. There are 4 types of logic gates in computer science. What do you mean? It means circuits, which is 0 or 1. The circuits combine with each other and makes the logic gate. And on the basis of these logic gates, computer perform the logic, our required logic, what we need. Be familiar with drawing and interpreting logic gate circuits diagrams involving multiple gates. Complete a truth table for a given logic gate circuit. Write a Boolean expression for a given logic gate circuit. Draw an equivalent logic gate circuit for a given Boolean expression. So if you see here in this lesson, we'll talk about the circuits. Computer circuit, which is wires, and you can understand one wire is can be on or off. So let's see. And I do hope for the programmers and for the A level students and for the other students, even university students, they can get this lesson. They can learn this lesson well, and I will try to carry with me the beginners as well. So binary switch, what is that? Electronic devices can only recognize the presence of, as I said, one circuit is, if off, light is off, it's 0. If light is on, it's 1. So here it says input, and A circuit is basically not closed, B circuit not closed, and output. The circuit will be like this. Input is coming. If circuit is not closed, it will not go. So in the above figure, this figure, the circuit is the current is not going after A. But here here the circle the current is going here, then current going A and B both sides, but they are broken, so it's not going next. So basically these are switches can be combined in different ways to create. Okay, so here in this page you will see two things, on and off. One circuit is either on and off. Second thing we'll learn here, by combining these circuits in different ways, or combining these switches in different ways, we will create simple circuits. We call them logical gates. So we will create gates from these logical gates. Electronic gates take one or more inputs and produce a single output. The output can then become the input to the next gate. Yeah, and so on to create a complex circuit. So we are basically going to build a circuit, logical circuit, and we will start from one circuit and join it with other, and join with others, so that it becomes a complex circuit. Okay, next. There are four types of logical gates in computer: not, and, or, and XOR. Each of these can be represented by graphical symbol. Let's see, and truth table. Let's see. First, not gate. If 0 is input, it outputs 1. If 1 is input, it outputs 0. Not gate, as the name is common sense, name tells you, the input, if off, output will be on. If input on, output will be off. So we will connect the circuit like this, that output will be the reverse of input. Okay, let's see how. This is the not gate symbol, and here is the truth table. Truth table we put A and P. A is input, P is output. And if A is 0, for example, as I told you, one current should be either 0, off, or on. So if it is off, output will be on. If it is on, output will be 0. So if input 0, output 1, if input 1, output 0. So it's reverse. And this is the logic diagram, truth table, and these are the formulas. So Boolean P is not A, and we will write it P is equal to not A. This symbol is not symbol. AND gate. Okay. So if you see not gate, basically here one input is coming and the other is not. But here in AND gate, there are two inputs are coming, A and B, and output is P. Now see the truth table. In AND gate, both the inputs should be 1 if you want to get 1. Otherwise, output will be 0. Means if this is 0, 1, 0, 1, 0, 0, 0, 0, 0, if these two are 1, then it's 1. Means if two inputs are on, then you can get on output in this gate. Okay, got it? Here's the truth table. A0, B0, 0, output 0. A0, B1, output 0. A1, B0, output 0. If both A and B are 1, then output will be 1. And we will write it like this and this, formulas. And this is the diagram, and this is the truth table. I hope now you understand how we can show these circuits. What is the OR gate? OR means if you get two inputs, if one of them is 1, output will be 1. It's very common sense things. If you are in the talking with the group of people, or minimum two people should be there, so you can say, okay, you and you, if you both have money, come with me. So if either one will not have money, they will not come with you, because you put and condition. You said if you have money and you have money, come with me. If you say if you or you have money, come with me, then if either one of them will have money, they will come with you. So this is the difference between and or. It's in our